Professor Mahmoud told me that I should tell to undergraduate students that they can switch their class to the other session by Professor Omar. Looks like it's more convenient for them to take that session. So Professor Mahmoud left to them to decide which class they want to stay. Which class they want to stay and which class they want to choose. However, today, based on the recommendation that we have undergraduate class, I prepared the slides for normalization, and I believe that now it's a boring session. It will be a boring session for you graduate students, but okay, we have to just review normalization. First of all, you remember that we had this database design session. We discussed about how to design databases, basically based on ER model and designing relationships. Now today we will discuss about kits, and then after that we will talk about normalizations, and we will discuss about four forms of normalization: first, second, and third, and fourth normal forms, and then this will be our class today. So, after deciding about the entities in the ER model, now it's time to consider the semantics of the data and refine our design based on semantics of our relationships. Basically, database normalization is the process of removing redundant data from the tables to improve the storage efficiency, data integrity, and scalability. In relational model, methods exist for quantifying how efficient the database is. Okay, these methods are called, these classifications are called normal forms, and there are algorithms to make the design of database normal. Basically, normalization generally involves in splitting existing tables and existing relationships into multiple ones, which must be rejoined, and adding more relationship to joining these splitted entities. Before getting into the normalization, we have to review about dependency between data semantics. An attribute A is functionally dependent on attributes B. If given a value of B, for B there is one and only one corresponding value for A. Okay. Suppose that we have a table of sales as shown here. We have sales representative number, the name of the sales representative, the pay class of that one, and the commission he gets in terms of money. Okay, so obviously there is a dependency between two fields over here. If you know the pay class of a representative, definitely you can compute and calculate the payment. Okay, the commission. So obviously this table has some dependency inside of between their fields and attributes. This is called functionally dependent. This attribute is functionally dependent on this attribute, and this is called functional dependence. So to show the functional dependence between fields, for example, here you can show that paid class can here's the value of commission, okay? But in order to define what pay class is based on, you have to have these two values, okay? For example, here, if the key of this table is sales number and a name, and if we put this constraint that the pay classes for each person is unique, then the key will be all of these three, okay? Then based on sales number, name, and pay class, you can decide about pay class. It means that pay class is not depending on just these two relationships, okay? So this is how we represent dependencies, and we will need this kind of arrows later on to decide about dependencies and fourth normal form and third normal forms. Okay, we call the set of attributes C a primary key if it determines all the attributes in a relationship, and no subset of the attributes in C is a candidate key. Okay, for example, here, if we decide that sales representative number and name is defining the attributes of this table, and pay class may be different for the person, but this is not a determining attribute, then the primary key of this table will be sales representative number, name. Okay, and for each person, we can have different classes. But hold on, there is a trick over here. Sales representative number and the name of the sales representative. Okay, there is also dependency over here, right? Therefore, for the key, but we just need the sales representative number of this table. Okay, so a key with more than one attribute is called composite key also. Good primary keys in a good design, good primary keys are not changing over the life of the database. Okay, so if you design a database and today we design a database and tomorrow you will decide to change the primary key of a database, it's obvious that you had a mistake yesterday. Okay, the primary keys should not be very long. Should not consist of many attributes. Why? The reason. It's unique, but why we don't like multiple values, multiple attributes, too many attributes? Confusing from the design point. Okay. One more reason.
Redundancy of data is fast.
Redundancy is not a case because it's a key, but efficiency of the database is very important, because when you are combining three attributes to compose a key, then the mechanism of the index will be very, very complicated for the database. DBMS is keeping B+3, okay, to track all of the records. And if you compose several attributes, this B+3 will be very complicated for the DBMS, and also DBMS should jump between the B+3s, which is very the efficiency. Okay. So foreign keys are again, to remind, foreign keys are those attributes that are keys primary key in another table, and they are showing a difference between one table to another. A value in the child, which is basically a value in the child table that matches with the parent table. For example, here, sales representative can have sales representative number and name, where sales representative number is the primary key, and if we have it customer table, then in the customer table, for each customer there will be several let's say representative number, but each sales representative number is basically a foreign key to sales rep table. Basically, the foreign key in the child table has the same value in the primary key, and the foreign key in many-to-many relationship goes in the many table, from many-to-many relationship to many table. Okay. So in a one-to-many relationship, the foreign key goes from many side to many side of the relationship to one side of the relationship. Okay. For example, suppose that falling on mine. Okay, suppose that you cannot see over here, right? Suppose that you have a table of dealership, which is dealer ID and address and phone, and cars sold, which is a VIN number and dealer ID. Okay, for each VIN number, we have a dealer ID, which is going to the same. So the foreign key, this is a one-to-many relationship. The foreign key from one-to-many relationship goes from the foreign key is going from the many side. This is many side, right? For each car there are several dealerships. This is not dealership. The dealership identification number is not here, right? It's repeated several times from this side to the part from the many side of the relationship to the one side. The one-to-one relationship, again, foreign keys are going from one table to another table. So normal forms are required to set of conditions are required on tables to improve the maintenance. Basically, normal forms remove processing anomalies for update. How they remove the efficiency for update. How they improve the efficiency of the update. When they are removing the redundancy, then you need to, when you are updating a specific attribute, you are updating less record because you don't have redundant data. But if you have redundant data, for example, several times you repeated in front of my ID, my name and all of my information. If you change my name, if you want to change my name, then you have to go to all of those places and update in order to keep the integrity of the database. So it improves the efficiency. It's required for the efficiency of the update. For example, how it improves inconsistent data, consistency of data. For example, suppose that in front of my ID number, several times you repeated my name, and then one record is updating one of those, one transaction is suddenly updating one of those records by the name, okay? Then in front of my representation of ID, my professor ID, for example, there are two different names. It's kind of inconsistency. So if you reduce redundancy, then you will reduce inconsistent data. And also deletion and addition are definitely is a kind of update that they are improved. So in order to make a table normal, you have to follow one general rule. which is basically all attributes depend on the key, and they just need to depend on the key. That's it. They are not supposed to depend on attributes other than the key. Okay? And this is a summary of normal forms. For example, for the first normal form, keys, and you define the keys and you remove the repeating groups, and also second normal form you define partial dependencies. Third normal form you remove transitive dependencies, and for the fourth normal form you remove multi-value dependencies. Okay, so now the first normal form is about removing repeated groups. Suppose that you have a table and that table has a primary key. So the table is normal in the normal form. It doesn't have any repeating group. What is a repeating group? Multi-valued attribute is an attribute that may have several values. This is the kind of repeating group. A repeating group is a set of one or more multiple value attributes that are related. Okay? Look at this table. We have a book titled Database System Concepts and Operating System Concepts. The first author is Abraham Silverschatz. The second author is Henry Forth. This is the ISBN. There is a multi-value attribute over here, and it shows subject of data, therefore the book, number of pages, and publisher. Again here, we have the name of the book, first author, second author, ISBN, subject, which is one noun, one attribute, and then number of pages and publisher. So the subject attribute is called multi-value attribute because you can have several subjects for a single book. Okay, so this is a kind of obviously this is kind of violation of no first normal form. There is another violation over here. What?
Redundancy of data. I mean, like both others are same. Primary.
Both of the authors are same, but if you see the schema, the design of the table, there is obviously. You see author.
Functional ISBN is different.
ISBN because there are two different books.
Yeah, two different books. Right.
Functional dependency of ISBN and
The primary key of
The
what?
primary can be anywhere in any column. It has to be at the first or something.
functional dependency of ISBN with title
Between author and authors, what kind of dependency?
and the
No, I'm talking about first normal form, violation of just first normal form. The first condition was multi-value attribute. I showed you multi-value attribute, which was multi-value attribute, the subject. Okay. Now, just look for repeating group. Repeating group is a set of one or more multi-value attributes that are related. Here, outer 1 and outer 2. These two attributes are representing one concept. They are both representing one author, right? So probably in this example, probably the sequence of authors matters for the book. Okay, but first of all, with this design, you cannot represent a book with more than two authors, definitely. Okay, otherwise you have to add another attribute, author 3, and for these two books, author 3 should be null, and you can have another author 3 for the another person. So this is not a good way to represent a table. Moreover, if these two authors, if the sequence doesn't matter, then it's worse because you are representing two concepts which are semantically one concept, which you are representing two data items which are semantically one concept, two different fields and you are discriminating some sort of. So if you want to write a query, then it will be very confusing. So obviously the table is not very efficient for storage. Why the table is not very efficient for the storage?
We have more than 300 sheet codes.
No, just this is okay for the table, but focus on this part. Why is that efficient for the storage?
Because the same author might have more books, which means there'll have to be more rows of the same author having different entries. So as a result, there will be more storage for a single author than you can group for a single author.
Let me correct it in this way. Suppose that this attribute is multi-valued, right? The size of this attribute is bigger or getting bigger or shorter, okay? So if the size of one attribute is getting bigger or shorter, the size of the record is getting bigger and shorter. So then you do not have the exact size for the record. If you don't have an exact size for the record, when you are looking for some record on the disk and you don't know where is the beginning of the disk by the computation, then you have to read all of the bytes sequentially to get to that record. But if all of the records are in the exact same size, then for example, if you want to get to the record number 50, you multiply 50 to the size of one record and you know where, on which track that record is existing. Then you move the head exactly to that track, okay? But otherwise, if the sizes are unknown, the sizes are different, then you don't have any idea where a specific record is existing by the sequence number of the record. So this is very important for the storage.
But the data is same. We can go right with. There are only 5 fields, and whichever the data we might give, if we multiply it with 50, we will go to the 50th.
Right. If the record is, for example, if here this subject can vary, okay, then the size of if you have different number of subjects, okay, then the size of one record will not be the same to the other one.
It's a row right there. It's a column. Column length will be fixed anyway. So
no, I mean, so for the subject at this year, you need an array or something like that.
no, in database, like
yeah, in the database, yes, but we are not talking about in the database. You cannot implement this in the relational database because you cannot have multi-value data items, except those databases created for this purpose, like NoSQL databases. Okay, but here for the relational database, this is not. You cannot implement this one because the size is changed. Okay, and the design does not protect data integrity. You mentioned the complexity is getting higher, right?
Yeah.
The complexity is also getting higher, and the table, as your friend told, the table is not scaling well. If you add more students, more books, then this table with this variable size of the report and with this structure is not a good table to scale up. So to solve this problem, what we should do is basically adding more rows to the table and removing those rows that are violating these conditions. So these are the explanation of violations of normal forms. We have more than one author field in this example. Our subject fields are more than it has a multiple value attribute, and the solution is breaking into different rows. This is the solution. Now the subject is I'm not showing the whole table. The table should have 6 rows. I didn't have a space, but the size of the subject is now consistent. This is the exact same size. You don't have multiple value attribute, and also authors of the book are not. You don't have author 1 and author 2. You have just one author, and from this table you can simply find out what is the author of who are the author of database system and concept, because you go to the table, you find each row with this name, and then you can add the name of the author to the list, and finally you will have the author. So now there is another problem. We have
2 rows for a book.
2 rows for a single book. You're repeating stuff. So now a better solution is to solve this problem is breaking tables and adding an author table and subject table to store two different tables to store different types of information. So that solution takes us to second normal form. So in the second normal form, we are resolving partial dependencies. What does it mean?
The rows which are not dependent on the primary key should be removed from the.
Right. The attributes are not dependent on the primary key. They should be removed. The attributes are not depending on the whole part of the primary key.
Yeah, full process.
The attributes, but they still depends on some part of a key, but they have to be removed. Okay. So what we are doing is basically we are creating a new table with dependency as a key, and then we move that part of the table to the new table. So the definition of the second normal form. A table is in second normal form if it is first normal form and no non-prime attribute is dependent on any proper subset of any candidate key of the table. What is a candidate key? I reviewed this several times until here. I believe that you know what's the candidate key. We have a primary key. Each table, each relationship have a primary key.
We can attach more than one column to the primary key to uniquely identify the record, so that particular key is called candidate key.
What you told is exactly correct, but let me explain it in this way. Any set of attributes that can identify a record is a candidate key. Okay? Primary key is one of those candidate keys. Any minimal set of attributes that can identify the primary key relationship. So let me. Okay, so in this table, the ISBN could be the primary key. Okay. Suppose that you have this restriction and limitation that no book can have similar names. Okay. Then ISBN is a primary key and also a candidate key. Also, title is a candidate key because title can also be a key. And title, if you know the title, you can identify a book. Okay? So, a candidate key is a set, a minimal set. No matter one, here the minimum, the number of the attribute is 1. But the minimal set of attributes that can identify the record. So, in order to make the previous example second normal form, we are breaking it into 3 different tables. Why? Because Okay, so we have this attribute that it is called author, okay? So it is depending on some part of the primary key. So it is depending on ISBN. So what we are doing is basically we are breaking it into different tables. So let me go to the other presentation. So this presentation has better examples. I'm using this presentation. It looks like. So for the to remind you, the first normal form, the requirement is each table has a primary key and minimum set of attributes which can be uniquely identified per record. The values in each column is of a table or atomic, and they cannot be dividable. So for example, here this was a table. In this example we have a student ID, advisor ID, advisor name, advisor room, class number 1 and class number 2. This is not in the first normal form. So what we are doing is we are breaking this table to, we are making this table bigger with using the class ID as the repeated rows. This is the solution for the first normal form, which was obvious. And for the second normal form, we have to remove the redundancy between two fields. So what we are doing is basically we are removing in this table, in the student table, this class number, the student that each student has several class numbers, okay? So in order to remove this redundancy for each student, the name of the advisor is repeated, okay? In order to remove this redundancy because of this class number, what we are doing is in this table, what is the key? The key is student ID, student number, and also advisor name, advisor ID, okay? So, but the class number is depending on portion of the key, which is the student number, okay? What we are doing is we are removing the student ID to removing the student ID and class number to another table, which is not shown here completely, but which table is this table is bigger, and the first table does not have any redundancy anymore. So now it's time to have third normal form. What is the third normal form? Remove the functional transitive functional dependence. For example, suppose that in this table, let's go to the in this table, this is the part of the candidate key. This is the candidate key. Suppose that each advisor can have one room, and then therefore is a combination of a student advisor ID or a student advisor name or a student advisor room can be candidate key. All of them are candidate key. Suppose that we choose these two attributes as primary key, okay? So if we choose this attribute as primary key, then advisor room can be depending on this value, which is advisor name. Also, advisor name can depend on advisor room and then depending on advisor ID. Therefore, these are called transitive dependencies. It's kind of comes down. So sorry, in this table, just the student is the key of this table, and this table is the student is the key. So in this table, the table number, the student table, we have the advisor ID can determine advisor name. And advisor name can determine, sorry,
Professor, it's not visible.
advisor room. And advisor ID is defined by can determined by student ID.
Professor, it's not visible.
The color of the ink is not
So
good.
let me change it. Hold on. Okay, so let me draw the notation of the dependencies, functional dependencies, as I mentioned before. Okay, the advisor room. Can you see that?
Yes.
The advisor room can be determined and identified by advisor name. Okay, if you know Professor Mahmoud is an advisor, you can find his room because it's the room. The advisor name can be which advisor has a room, and if you know the advisor ID, then you can find out the name of the advisor. And if you know the student ID, you can write the advisor ID. Okay, so this is transitive closure, right? This attribute doesn't depend on primary key. This is the only primary key you have. Okay. Again, this attribute also doesn't depend on doesn't depend on primary key. What we should do is we should take out these two attributes into another table. Now, in the third normal form, as I told, we break the student table to two tables. One is the student table, one is advisor table. One is the student table, which has the student number and advisor number. One is the advisor table, which has advisor number and corresponding information. Again, we have the registration table. We have the registration table that we had before. Therefore, after doing the third normal form, instead of two tables, we have instead of two tables here, we'll have three tables: the student table, advisor table, and registration table. Okay, before jumping to the fourth normal form, which is very more complicated, would you like to have a home classwork and do some classwork? We don't have very much time, but we will have a
సింపుల్ తెచ్చుకోండి
Okay, so would you normalize this table 5 minutes?
It's not much.
2, 3, normal. Start. Don't need to stop. Go ahead. Who is done? You're done? What? Card in the second of Chevy value. Chevy value is a good card. Let me normalize this into normal form. To make it normalized, what you should do is the first normal form. First normal form, we should remove this multi-value. Then we will have 4 rows. Also manual, Malibu, Focus, Andy, Jason, 1 to 3, 4, 5, 3, 21, 25. Okay, now I made this table. What is the key in this table? Just driver ID. You have 4 rows. If you have driver ID, for example, 1, 2, 3, there are really 2 rows. So driver ID by itself cannot identify a row.
Driver ID and
A ticket can identify
Driver ID and ticket number. This is the driver ID and ticket number. Okay, so is this second normal form?
No.
Why? Because the driver name is just depending on driver ID. Therefore, driver name is just depending on partial of the primary key. Car name is depending on driver ID. Again, this is partial of this key. So, all of these attributes, transmission, car, driver, and age, all of them are depending on driver ID. Only ticket number is different. Okay? Then in order to make it different, in order to make it second normal form, what should I do?
Driver table and driver ID and ticket should be separate.
Right, exactly. So I will remove this. This will be one table. And this will be another table.
Driver ID.
Driver
You can have the driver name, right? Why it need to be driver ID?
Yes, but okay, to decide which attribute should be the key, we prefer to have numerical attributes as a key. Numerical operations. Okay, this is one more point that you have to follow. Numerical attributes are better for primary key, to be primary key. 453, 453. What is the primary key of this table? Ticket ID. What is the primary key of this table? Driver ID. Suppose that each car just have one type of the transmission, okay? So, or two. Oh, okay, sorry. Yeah. Okay. Now, so this is now second normal form. Is it third normal form or not?
Yes.
Is it?
This is not third normal.
This is not third normal form. Why?
The car has to be separate.
Yes, because transmission depends on the car.
Yeah.
Car depends on the driver ID.
Yeah.
Therefore, transmission is not directly depending on driver ID. Okay? You remember the transitive dependency. Transmission can be determined by car, and car can be determined by driver ID. Okay. Therefore, this is not directly depending on this. What should I do?
Driver ID is
I should remove this. I should separate this table into two tables. One should be for car ID, car and transmission. The other one should decide about the driver ID and also car.
So we can associate the car with the driver ID.
It can be another table, right?
Yeah, that's what I said.
Right. But in this table, this is third normal form.
How is it third normal form if the car is still there associated with the driver?
Okay, so
I mean the driver ID
you
will
can
be the car, right?
So driver ID.
Yeah, the second table will have the driver ID, car, and the transmission, right?
No, the second table should have car and transmission. Each car has a type of transmission.
Yeah.
Okay?
The car is defined by the driver ID.
The car is defined with the driver ID.
Yeah, so driver ID also points to the car, right?
Driver ID points to the car.
Yeah. So
Okay. This is normal. Third normal. Why? Because the car is depending directly on the primary key. You don't have the third. If we had some other field over here, depending on the car, for example, AC, Boolean AC, car has AC or not, then that should be separated, which is going to this thing. So this is third normal form right now. So we got to the three tables. Shall I erase it? So the most complicated part is now. Okay, the most complicated normal form we learned. The most complicated is not forced normal form. There are more normal forms, fixed normal forms, ECNDF, what other types of normal forms that we are not required to consider. We put this in the parentheses. You remember later on that we normalize right now, but later on maybe exactly for the efficiency and in order to improve the response time for some queries, we denormalize sometimes. And we change the design of the table. So this is not written on the zone that we have to follow all of these normalization rules every time, but in the case that in daily applications we are doing normalization, but sometimes it is required for purpose of improvement of the efficiency to denormalize. Okay, the most complicated form of the normal forms that we are studying is forced normal form. The table is a forced normal form if it is a database is a third normal form. If it is a forced normal form, it is a third normal form, and for every one of its non-trivial multi-value dependencies, X is super key, that is, X is either a candidate key or a superset of those candidate keys. This can be explained better with an example. Suppose that you have this table, okay? This is a many-to-many relationship. Restaurant, pizza variety, and delivery area, okay? So, by restaurant you can decide about pizza variety. Also, you can decide about delivery area, okay? So, can we break down this table? How?
Two tables, restaurant and pizza variety, restaurant delivery area.
Okay, perfect. This is, if we divide these two tables into, into two tables, each of which represents the part of the information. This is called multi-valued. This is called forced normal form or multi-valued normalization. So basically, what we have here is a many-to-many relationship. Okay. All of you can see three types of areas: Springfield, Shelbyville, and Capital City. Okay, all of them repeated. Here, pizza variety, different types of pizza varieties: thick crust, soft crust, and thin crust. Okay, so three types, all of them repeated, and different restaurants, all of them repeated. Therefore, in this table, none of these are, all of these are primary keys. Okay? All of these attributes should be primary key. A line pizza cannot identify the whole record.
If they need two, we can identify the other.
What?
No, we can't.
No, we cannot go from the backward. We cannot decide from the pizza variety, the restaurant, or we cannot define the delivery area. But we know that each restaurant has different types of pizza cooking. So we know that restaurant has a one-to-many relationship with pizza variety, and also restaurant has a one-to-many relationship with delivery. Therefore, we can divide this to these tables. Each restaurant, the type of pizza they are cooking, and also each restaurant and the type of pizza, the area that they are covering. In the the underlying line is removed here, but we should be underlined. Restaurant and delivery area, both of them are primary keys. Okay, this is a many-to-many relationship. Okay, this is called fourth normal form. Okay, so I'm not going to cover fixed normal form actually. It's more complicated and probably you don't need it. So meanwhile, I'll give you a homework at this moment. Let's talk about, before the homework, let's talk about the projects. You need to decide about your groups and also the topic of the project at the time. Because now we finished the part for designing the database, and you are now able to design a database. You are able to recognize entities, recognize relationship between those entities, then identify your tables, identify your keys, and then normalize it, and then you will have a database. Okay? At this moment, you can design and implement a database completely. So before jumping to the SQL query, you have to decide about the table, for database project. So, how many groups do we have? How many people? All of the people are registered, right? Do you roughly know how many of the people are not attending or absent? Okay, if we assume that we have this number of people, can have a group of 2 or 3 people. Okay, so for this course, group of 2 or 3 people is an appropriate number. So Have you formed your groups or not?
Yes.
One group just formed it. They have decided. Nothing else. Okay, so for the next week, decide about the group, and you need to implement a database with at least 9 entities. The database with at least 9 or 10 entities. If you are a group of 3 people, you have to have 10 entities. If you are 2 people, you have to have 9 entities. Okay? So from the applications around yourself, just pick up one simple application. Each entity should not have less than 4 or 5 attributes. You can have entities like car and not just AC or not. You know, car has a lot of information.
45 people.
What?
45 people total registered to the course.
Total?
45 people have registered to the course.
40 people?
45.
35.
Okay. With distance learning or without distance learning? With distance learning? Or
No,
just without distance? Okay. I think 16 people are ordered. Okay, 45.
315s, 15 groups. Groups of
Sometimes we have 2 people. Okay, let's say we will have 15 groups. Okay, I will start a discussion in Canvas. Okay, and every group, whoever picks a topic at the beginning and put its topic or her topic, her group's topic in the discussion, then that topic is going to that person. So, and you cannot have repeated applications. Two groups cannot work on the same project. So, in order to break the rule of copying projects and resources, let's do that. One more thing is that I talked to Professor Mahmoud, and I will apply for Amazon Web Services resources, educational resources for this class. If we get this grant, then each group will have one Amazon Web Service account until the end of semester, I believe, for free, for a specific amount of computation. Amazon Web Services has its own rules and regulations. Please keep the pride of University of Bridgeport and do not violate any rules, and just use the account for educational purposes. You know, do not run Bitcoin miners on the accounts. Okay, this is a free account by University of Bridgeport. So this is the point that if we get that grant, then you can run your project in your Amazon Web Services. This is your option. If you learn how to work with Amazon Web Services, it will be very good. Many companies out there are working with this kind of cloud. You know, and cloud computing is a very hot topic right now in the industry. So just be prepared for this purpose, and decide about your projects, and also start working on that. Probably the due date for the project is approaching. Okay, next week or the first phase will be finished the next week. Okay, so we didn't have attendance sheet. Okay, so one thing is that I can take picture.
That will not be good. We don't know the name side.
Okay, so we cannot. How many people are there in class? Just 4 people are. Everyone is present. Just 4 or 3 people are absent. Okay, so I didn't. No, I don't have it. Okay, so see you on Thursday with your capital projects.
You can take anything.